Hello, Intro to Chemistry students. We are, you should have received books. Hopefully you're watching this video on Wednesday. Books should arrive for this course on Tuesday. So you have a series of worksheets that go along with the book, and I'll kind of I'll obviously assign those after certain video clips as we go forward. So what we're going through, and I kind of I'm skipping around a little bit. Right now we're doing chapter 8, but also you see we're doing some of chapter 9. So we're combining everything that has to do with covalent bonding and covalent molecules. And so what we're doing with what we did first was actually the chapter 9 part, which was the naming. And then we started the lab on creating those molecular models, which I know we got about half done with. I think we will finish that. I think what I will do is make an instructional video and kind of build those with you. I really don't know what else to do, but I want us to maybe complete that together. I wanted you to do the lab first as kind of more of an inquiry and come up with some patterns that you see. I think that's not necessarily going to be how it happens now based on what this next month is looking like for you. So just so you know, we were using information from the book anyway. You just didn't have that physical copy of the book before. Now you have that. I think it's important for you to have that reference. And so, yeah, you'll just have that kind of that background to refer to. But my plan is to go through and make instructional videos for you that explain these processes as well. So here we go. This is just a review. We talked about this already, those naming of those molecular compounds. So you should have that already in your notes and in kind of your little toolbox of things. So moving forward, here's what things look like. So the objectives in this section are to identify the information that we actually can get from a molecular formula, and also to describe units that define molecular compounds and ionic compounds. So we are going to do a little bit of how do you tell the difference between the two. But when I see something like this tells me that I have one carbon, okay? I have one carbon atom, and there are 4 hydrogen atoms. So probably this structure there's a central carbon, and you wouldn't necessarily know this yet, but by the time we go through this chapter, you certainly should be able to do this and know where those atoms are arranged, and that it would be more that instead of, sorry, I'm writing with my mouse, so this is, so this is not it, just so you know. And we're gonna look at the reasons why and the rules behind why we know that it is this more branched structure, and definitely this ain't it, okay? So let's look at kind of why that is, if you will. So before we get into too much of that, I do want to talk about those differences between ionic and covalently bonded compounds. So ionic, remember, is what we did last, and we said there's a positive ion and a negative ion, and they're attracted to each other because one is positive. Cations are positive and anions are negative, but they're attracted to each other because of that difference in charges. Also, in ionic compounds, if you have a compound where one of the atoms is a metal, that is always ionic. So metals are always ionic. The other type of ionic compound might be hydrogen, might be the positive ion that it has instead of a metal. And those are really the only options. It's almost always, I shouldn't say always, almost always, because it could be ammonia too. Remember, we have that ammonia, that NH4 with a +1 charge. That's a polyatomic positive ion. But if it has a metal, it's always ionic. If it has hydrogen, most of the time it's covalent, but in some cases hydrogen is that positive ion, and it's ionic. Ionic compounds have strong bonds that hold those individual atoms together. They are also good conductors. And I wish you were here because we actually would do a lab that kind of showed you that. But the way that ions come apart or break apart in water actually allows these positive and negative charges floating around in the water. So if I have something like table salt, which is sodium chloride, right? So sodium is a positive ion, and it combines with chlorine, which was a negative ion. But when these go in water, they dissociate into the separate ions that are charged. And because of that difference in charge, they're actually really, really good electrical conductors. Where things like, alcohols or sugar, which are covalently bonded things, not good conductors in water. Ionic compounds also form crystal structures. We talked about that too. Covalent compounds never contain metals. These are always about sharing those electrons. They're weaker molecular structure. They may be stronger bonds between individual particles, but the actual structure that holds together is weaker than those ionic compounds. These are terrible conductors. They're not good conductors at all. So if you dissolve sugar in water, for example, sugar is covalent. That's not going to be a good conductor. And they don't form specific crystal structures. So you might say, oh, sugar does crystallize. But if I look at table salt, every single crystal is a perfect cube. We see crystals of sugar, but they're misshapen and they're all completely different. Just like crystals of water, like how snowflake, so water is a covalently bonded compound. That's why every snowflake is different. Those crystals of snow are, every one of them is unique. They don't form the same shape every single time. That's an example of a covalent compound forming a solid. So information that we get from molecular formulas then. So when we say molecular, we're also talking about covalent. It's the same thing. Molecular compounds and covalent compounds are the same thing. Sometimes we refer to ionic as, molecules, but technically from a technical standpoint, molecule refers to something that's covalently bonded together. But anyway, so what do we know, regardless of whether we're talking about ionic or covalent? What do we know from this formula? Well, we know this one, right? Has 6 carbon atoms and 12 hydrogen atoms and 6 oxygen atoms. We know that C stands for carbon, so we know the numbers of each type of atom and the ratio. This would be like a 1 to 2 to 1 ratio if we divided all of these numbers by 2. We could get that molecular ratio, which for some chemists that's really important in their calculations. All right, and we kind of talked about this already, but I want to make sure that you get this in your notes. So these covalent bonds literally means they're going to be sharing electrons. And technically, we talked about the definition of molecule already, a neutral group of atoms joined together by covalent bonds. So with that information, you should be able to complete worksheet 8.1 that goes along with your textbook. So you should either have received that digitally or if you don't have internet, then in some sort of packet form. But if you're watching this on Tuesday, I just found out that today is National Bunsen Burner Day. So I thought we at least have to light a Bunsen burner today and do something with that. So remembering safety, I'm wearing my goggles. I'm actually wearing gloves, which you wouldn't normally need to do, but I'm actually going to do something fun for you today. Wish you were here. I'm using 2 hands to light my Bunsen burner. This is a really nice flame because you can hardly see it, which means that it's complete combustion. You should probably not try this at home, but I'm going to toast a marshmallow today over my Bunsen burner flame. I'm going to try not to start that on fire. I wish you were, started on fire a little bit. We all know there's that fine line between getting that perfect marshmallow and getting that black, not so great marshmallow. There we go. And I think I'm going to have a s'more. I hope you're enjoying your time off, and I hope you're going to enjoy the schoolwork that you did get. Please feel free to email me if you have any questions. I think I'm going to enjoy a s'more. Have a good one.